In the command window, type run important. It shows this message. We can help your research and engineering project. No matter of the size and the topic of your project, we can help. Visit www.EEprogrammer.com. This is Michael Wu from EEprogrammer.com. Today I'm going to talk about how can we determine the possibility distributed function based on the sample data. Now, first of all, I'm going to create some sample data. Assume mu is equal to 2, sigma is equal to 4. I'm going to create some normal distributed data. Now, to create some normal distributed data, we can use long-range. Now you can see the help function. Now, I'm going to create the data now. R equal to long-range mu sigma and 10,000 data point. Now I'm going to create some random data. This time the random data is uniform distributed data, Q. So I have already created the R, which is normally distributed data. And let's see what is the meaning of RAND in here. In the help function, we can see that R equal to RAND and return a standard uniform distribution on open interval 0 to 1. So it is uniform distributed data. After we have Q and R, then we are going to make some plot to understand the distribution of R. Oops. Okay, do it again. Now, the distribution of R is like this. Now, the center point is roughly around 2. So that is a MATLAB did its job creating a distribution, normal distribution. This time, MATLAB also did its job create a uniform distribution of Q, okay? Now let's see what is long fit. Now in here, you can see long fit basically return two value. One is the sigma hat, one is the mu hat. So if the data, if some sample data, we put it in, it will return you two values. Now, however, it depends on what kind of data do you put it in. Do you put in normal distributed data or not? Let's make a plot of R. That is a histogram of R. Now, I'm going to fit the Q data and find the sigma and mu. Now again, Q is uniform distributed data and I use long fit in here. I put it on the second plot. You can see the distribution is not as same as the first one. It doesn't have a long tail. It is very sharp. So it is not really a normally distributed data of Q. Now I do the same thing of using long fit for R. And I use green color on the second plot and make the plot. You may not be able to see well, so I'm going to make another port so you can see better. Now support 211, the first port, histogram of R. And this time, the second port only from the data prediction of R. It generates the same kind of string. So you can tell the data is pretty much normally distributed by using this approach. Okay, now I set the mu is equal to again. This time I do another example using EXPRND. It's an exponential distribution. Now I create a set of sample data R using exponential distribution. Now I make the plots. The first plot in here is the histogram. You can see it looks like this with mu is equal to 2. The R is the exponential random data. It looks like this. Now if I use long fit for the data R, what will going to happen? Now I will still get the mu value and still get the sigma value, right? I still get something from MATLAB. But now let's see the second plot. The distribution looks like a bell shape. This bell shape distribution does not match with the first one. So let's see, there is a function EXPFIT. That is the exponential fit. So as you assume your sample data is exponential distribution, and then you fit it using the exponential distribution. Now let's see what's going to happen with the data set R. We know we generate the data using the exponential random, so it should fit perfect, right? Let's see. I make the plot for the first one. For the second one, you can see the curve, the green curve in here. It matches with the shape of the data distribution. So you can say for sure the data is exponentially distributed.
If your research or engineering projects are falling behind, EEprogrammer.com can help you get them back on track without exploding your budget. Let us know what you need. You'll find relief here. Visit EEprogrammer.com. We can help you.